Hello everyone. So today we will solve the fourth problem of this contest, that is hard mark, and it is a good problem of digit DP, right? So I have given you a hint that the problem is of digit DP. So let's move into the problem statement first, right? So you're given two integers L and R and a string directions consisting of exactly 3 characters and 3 R characters. So there will be 3 D characters and 3 R character as well. For each integer in the range L to R, you need inclusive perform the following steps. If X has fewer than 16 digits, you will pad them to the with leading zeros to obtain a 16 digit. What does this mean? This means that, wait a second, let me open my whiteboard. Yes. So if the digit which you have has less than 16 digits, right? Let's say it had only 385, right? So all the elements before this 16 digits should be created. So there will be 13 zeros, leading zeros, and you will get an ultimate number for it, right? Now place these 16 digits in a 4 cross row major order, right? The first 4 digits form the first row from left to right. The next 4 digits form the second row, and so on and so forth, right? So what does this mean? This, let's say if you had a number, the initial digits are, let's say, 1, 2, 7, 9, and so on and so forth till 16 digits. So how will the grid look like? The grid look like 1, 2, 7, 9. Let's say A, B, C, D. This here A, B, C, D over there, and so on and so forth. So you understood this digit will come at this place. This digit will come at this place. This at this, and so on, right? So starting at the top left cell, what is given? The row 0 and column is 0. Apply the 6th character of the direction in order. D means to go +1 by row. R means to go right, means to go on the column 1. So you are standing at this position. If I give you a D, you will go down, right? And R means right, going right, right? So when you go down, you do a row +1, that is I +1, and if you go right, you do a J +1. In our simple terms, when we use variable names, we say that if you are at, let's say, row comma col, right, and if I have given you a D, you go to row +1 comma col, you stay on the same column. And if I give you a R, you go to row comma col +1. I hope till this point things are clear to you. Alright, so record the sequence of digits visited along the path, producing a sequence of length 7, right? So if you are standing at, let's say you are standing at 0, 0, let's say not, you will be standing at 0, 0, and I give you 6 instructions, right? So there will be, in total, you will travel on 7 grids, travel on total of 7 cells, not grid, 7 cells. Am I making sense to you? I hope so, right? The integer x is considered good if the recorded sequence is non-decreasing. So what does this mean? Whatever the sequence, the 7-digit sequence you will get, 2, 3, 4, 5, 8, 1, 2, 3, 4, 5, 6, 7, right? So this sequence should be increasing in order. I hope you understand this. Like this should be 2, 3, 4, 5, 6, 7, 9, right? Something like this, right? Or rather 2, 2, 2, 2, 2, 2, 2, 6, 1, 2, 3, and 4, right? This is also increasing one, right? It is not said strictly increasing, it should be non-decreasing. That means it should be increasing, right? And strictly and if they have not mentioned strictly increasing, that means this element could be less than, this element should be greater than equal to the previous element, right? The problem statement, you need to return an integer representing the number of good numbers in L to R, right? So I hope till this point the problem statement is at least clear to you, right? Let's look at the first 10 constraints which are given to us, right? Because that will give you a big hint. Why I'm saying so, you will understand it. So constraints is 10 to the power 15, right? So this means that you can't travel and generate all possible values, all possible. Would you be able to generate in 1 second in C++ or in any language 10 to the power 15 operations? No, you won't, right? So whenever you come across these type of constraints, you get a bigger hint of something. What is that bigger hint? The bigger hint is digit DP. Now why digit DP or maths? But this is not a math problem. There might be a mathematical solution to it, but I don't have one. I have a solution of digit DP, right? So keep it in mind that whenever you get a constraint problem statement which asks you to solve it, the constraints are 10 to the power 15, 18, or a very huge constraint, then it is openly challenging you that come and do digitdp or maths, apply maths, right? So we will solve it using digitdp, right? Now if you have no idea of what digitdp is, don't panic. This problem is pretty simple. I will walk through the easiest approach for digitdp, right? Let's first try to understand what is the statement of the problem, right? What is the thing that you should keep in mind while you are solving this problem, right? So let's say if the starting value was 8, right, and the given string was dddrr, right? Wait a second. So this direction strings could be anything, right? So first let's see if it is dd. Oh no, this not this one. Where did it go? DDDRRR, right? So let's say you had a 4 cross 4 grid, right? 0, 1, 2, this 1, 2, 3, 4, right? 0, 1, 2, 3, 0, 1, 2, 3, right? You are standing at this and the given string is DDDRRR, right? So if you go down, you reach to this point, right? So this is a cell. You will go to 0, 0 and 1, 0, right? Then again down, right? Down this one, 2, 0, right? Again down this one, 3, 0, right? Then right 3, 1, then again a right, 3, 2, and again a right, 3, 3, right? So tell me one thing, if I'm saying this should be your sequence, right? Let me mark this sequence as this is your sequence, right? Do you care whatever digit is written over here, if it's increasing or not? First tell me this thing. Are you concerned about these things? No, right? You don't even see this should be 1, this should be 2, this should not be 2, this can be anything but greater than equal to 2, again 2, this can be 3 or any value greater than 2 or equal to 2, right? It could be, for example, I'm writing, right? So do you even care whatever written here? Let's say it is written 1 9. Do you even care about it? No, right? Even though it can't be written, but still you don't care about that, right? So first observation was you need to know, right? You need to know what is your path, right? What does this mean? That you need to understand that you only want your paths sequence to be increasing. That's it. That's what I have asked to you. So you don't even care that whatever written over here is whatever, right? All right. Now let's move to the next thought which we can get, right? So till this point you understood that you need to find a path and that path should be increasing on. Your task is to make sure that the path gets an increasing value, right? Now let's look at my second observation, right? My second observation is something like this. So now the problem is shifting from observation to digitdp, right? So what we say in digitdp is, for a range L to R, if you want to find a solution for this range, what is better is solve the problem from 0 to R, then solve the problem from 0 to L. The same function does that, and you simply call this as answer 1, call this as answer 2, and you subtract answer 1 minus answer 2, and that will be your answer, right? Means let's say your value is 100 and 1 is 50. So you find the answer till this point, and simply subtract it. You will get the answer, correct answer, which is from this to this. That is what we are getting, right? So this is how digitdp will look like, right? So this is the one concept, right? Great. The second concept which comes into play is this. Listen to this, right? Let's say we are standing at on path, means the current index, whatever the index is, that is on our path vector, right? Means we are concerned about its value. We are concerned about its value. right? So in that case we also need to make sure that we, let's say this value was x, so you need to make sure that this value, if it is on your path, and this was the previous value which was on your path, right? Let me scroll down a bit. Yes, so previous value which was on path, right? So if you have this value should be at least greater than equal to x, right? All right. So till this point, I hope everything is making sense. See, I'm going slow, I'm repeating things because I don't want to cramp those things like this is this and this is this and we are into the solution. I want to go a bit slowly, right? Now let's say we are on path, right? This value was on path of index was equal to 1. What does this mean? That we are concerned about its value, right? If we are concerned about its value, what can be the conditions? First thing you should know is tight in digit TP, right? What does this tight mean? Let's say my tight value was 1, right? If my tight value was 1, this says that we are set on boundaries, right? Like if you say that my tight value is, let's say, first let's look at if my tight value was 0, right? If my tight value was 0, what does this mean? This means you can pick any value at that position. You can pick any value at that position, right? Means if you are like, if your upper limit is, let's say, 9, you can go to only till 9, right? So if you are at this index, right, so can you place a value? Not upper digit 9 will be a bit hard to understand. Let's say at this position I'm saying whatever written 5 6 1, and here it is written 7, right? So when you are at this index, can you place a value 8 over here? Definitely not, right? Let's say you greedily placed a value 7. I don't care about these positions, I'm just talking about this one, right? Let's say you placed a 7 over here, right? And after this it was 3 written over here. Now when you place a 7 at this place, your tight becomes 1, right? What does this mean? That in future, right, in future index, whatever value you can put at the next index, that is a constrained one. You can't put a 4 over here, right? Because it will exceed the value. So how did we came to know that? We just simply stored a variable called tight, right? So what does this tight do? This tight will tell you that if my tight is 1, I am bound to stay in my boundaries, right? But what if my tight was 0? What does this mean, right? Wait a second. So if my tight was 0, that means you have definitely put a value which is lesser than 7. Let's say you put a 6, right? Now do you tell me, right? Let's say I have written 5 6 1 at this position, right? For understanding I'm keeping it, right? Now if you put a 6 over here, what are the possibilities of you putting a value at this point? It can be anything. You can put a 9 as well, still it won't exceed that value, right? Is it exceeding this value? No, this value is correctly in the bound. So tight gives you the thing that if my tight is 0, I can pick any value, whereas if my tight is 1, I am bound to be in my limits, right? Great. So till now we understood tight, we understood how my on path will look, right? And we understood how we will apply, how will we find R minus L range, right? Now the problem is almost over, right? Are we sure the problem is over? Let's look at it, right? So what I'm trying to say, you can find what your limit will be. You will find your limit, right? Find your limit. See, whenever you are solving these kinds of problems, right, in future also, in interviews as well, you need to be a bit sure that whatever function you are writing will definitely give you a solution, right? So int limit is whatever my upper limit will be, right? Upper limit. You can find upper limit. How will you find? As we saw, if my tight was equal to 1, right? So limit will be s of I minus 0, means that element, right? If it was 7, so it will be 7, right? Else your limit will be 9. You can go till any value, right? Now what we can do is we will simply run a for loop, right, which will be my current value, right? Current value starts from 0, goes till the limit value, right? What we can say, if it is on path, if on path of that index, right, we will see how will we find that which index is on path and which is not on path. Remind me for a bit. But as of now, how will you sorry If on path is equal to 1, what does this mean? That that element will be in my sequence, right? So if the element is on my sequence, you tell me, pause the video and say, if you are on path, then what are the conditions you need to check? The first condition that you need to check at that point is your current value, right, should definitely be greater than equal to your previous value. Now you can understand that if I am writing a solve function, I need to have a type. I also need to have a previous value, whatever my previous value was, right? We are going to, means we are coming close to the solution now, right? Pay close attention. So we will have a type, we will have a previous value, right? So if my current value is greater than equal to previous value, then that gets added to my answer. So answer plus equal to, you will call the solve function and have the changes, right? One thing you need to make sure while you are on this is, if your index or if your current value is equal to type, right? Equal to limit, not type. So if you are on the limit value, right, then what will you do? Simply think of it. If your current value is limit, you are restricted for the next positions. You are restricted to use the value, right? But how? Right? You will simply say, if my type was 1, right, you will pass 1 as my type. If my pass was 0, simply keep it as 0. What does this mean? You will say, bro, you are speaking like you have read the code and you are saying, no, I'm not saying that. Let's say you had a 6, you had a 4 and 3, right? So if you are at this position and you place a 3, your type becomes 0, right? Let's keep one more value at this place called 5, right, for your understanding. So your type becomes 0, right? So now in future, you can place any element in future with a type value of 0. You don't need to change it. You don't need to change it, right? Am I right? You can place a 9 over here. You can, let's say you place a 6 and now you're going. So this is currently in your bound, right? But let's say your tight is 1. Now things get tight, right? So you placed a 6 and you placed a 4 at this place. Now what you can place? You can place any value. Let's say you have reached the limit. Limit will be at, for this position, what will be the limit? Limit will be 3, right? So limit is 3. You reached limit. You say, what should I pass? If you are at 3, what should you pass? You should pass tight as 1, right? Let's say tight was 1. Let's wait for a second. If the value was 3 and now your tight will be 0, right? So when you reached at this position, limit was 3, right? What are you able to place at this place? You can place anything, right? What will be the tight? If your value is 3, what will be the tight? Tight will be 0, right? You don't need to take care of things. I will take care of it, right? So tight is that place, right? So you will pass, if your current value is equal to limit, you will say, okay, if my tight was 1, if my tight was equal to 1, I will pass 1 as it. If my tight was equal to 0, I will pass 0 in my function solve, right? And we will find the value as these, right? So if my on path is equal to 1, right? On path of that index is equal to 1, then only I am concerned about these things, right? What if your on path was equal to 1, 0, right? I hope you are understanding on path equal to 0. What does this mean? This means that if all those 7 indices, right, we will mark all those 7 indices which we had earlier, right? How we will do that, I will show you as well. But let's first look at DigiTP. This thing is, I think you will not find it hard, right? So except for those 7 index, all those on path will be equal to 0, right? You can simply say, if on path is equal to 0, you don't care, right? So you simply check care of tight and all, right? If tight, whatever my tight is, right? If you reach the limit, if limit is equal, if your index is equal to, or your current value is, see, you can't exceed your, even if you don't care about it, right? You can't exceed these values from, let's say, the value which you can place at this place is 6, right? Because ultimately it's a string that will be formed, right? So at this place you can't place a value 9, right? Because that will exceed your R value, right? You need to take care of these things as well. So you don't care, but your value should be pretty much in your limit, right? as soon as you will see the code, you will understand what I am trying to say. This is not a thing to panic about, right? So if you don't care about it, right, if your limit is equal to your current value, you will simply pass the type as the value type was. If it was 0, pass it as 0. If it was 1, pass it as 1. Else, if you are not on limit, you can pass type as 0, right? Type equal to 0, right? In that case. Now let's look at what are my 7 indices I'm talking about, right? Like let's say this one, right? How will you create on path? See, if you are solving a digit DB problem, this won't be a tough one for you, right? DDD, RRR, right? So you are at this position, so you mark on, you will create a on path indices, right? Which is of 16 digits, right? So 0 gets marked as, let me create this 0, 1, 2, 3, 4, 5, 6, 7, 8, dot 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 dot. I don't think I need to mark till 16, you will understand, right? Rather 15. So you are at this position. What happens is you will create on path. You got a D. Whenever you get a D, you see you got +4. How I'm saying this? You skipped 1, 2, 3 and reached the 4th cell, right? So if you count these as cell numbers, now you will, like, how are we going to write the solution or the string? The string first goes from left to right, then again goes down left to right, then again goes down left to right, again goes down left to right. So this will be the 4th index, right? So whenever you get a D, you mark this as 1. You got a D, you say okay, +4 should be marked as 1. Again you got a D, right? This will be which index? Again a +4, so 8 will be marked as 1. Again a D, +12 will be marked as 1. You got a right. Whenever you are getting a right, this will be only a +1. I hope this makes sense to you. If you are standing at this current cell, if you are going a cell down, then you are skipping 4 cells because it's a 4 cross 4 grid. If you are going right, you are only getting a +1. Why? Because only +1 is getting added to it, right? So 13 will get marked as 1, 14 will get marked as 1, and 15 will get marked as 1. So this is the on path we will create. After creating this on path, I have showed how we will apply digit DB to it, right? So if my solve function is there, I do have a solve function. What were the changing parameters to it? Index was changing, previous value was in fact changing. One more thing which was changing was type. Was anything more changing? No. You need to have a string s with you, right? Now let's look at the base condition. What was the base condition? Base condition was if your index is equal to 16, you reach the end of the cell. If you reach the end of the cell and you haven't returned anything, return a 1, right? What does this mean? This means that you have a valid sequence, right? Great. Else, let's look at what more can be done, right? So we will find the int limit. I have shown you how to find limit, right? After finding limit, you will run a for loop from current value 0 to limit, right? And if it is on path, you definitely know what we need to do, right? If it's not on path, you definitely have understood what we need to do. If not, you will see the code. That part is not tough, right? So that is it for the problem. The logic must be clear to you. Let's look at the code, right? So let's start from the scratch, right? Wait, give me a second, right? If you have any doubt, like if you don't understand what I intended to do, you can definitely ask. It's not a tough problem, right? So first let's create a string. String s1 is next string. We will pass r, and string s2 is l-1. We will pass l-1, right? Let's go to next string. How are we making string, right? Whatever the value is given to us, we convert that value to string, and if its length is less than 16, we will be adding padding zeros, right? What does this mean? If the length is, if the string has, let's say 6, 7, 8, 9, 10, 6, 7, 8, 9, 1, 2, 3, 4, 5, so 3 and 3, 6, 8, so all the elements before it 7 digits should be 0, right? This will be your string, right? So you will create this string, right? Why I have written a function? Because we need to do it twice. So just to avoid repeating tasks, we have created this function, right? Vector of int on path, right? What does this on path do? We are on cell 0, we will say 0 cell should be marked as 1, right? Because that is on our path, right? Now we will go on the strings length, right, that is less than equal to 6, it is clearly written that there will be 3 cells, 6 characters, right, 3D and 3R. So we are finding the character, right? If the character is D, we will do cell plus 4. If the character is R, we will do plus 1, right? I hope you understood this thing. Why are we doing a plus 1? Because if you are standing at this position, you did a D, then you went to this position, and this was 0, this was 1, 2, 3 and 4, right? Alright, if you are doing a R, you are doing a plus 1, right? And you will simply mark that cell as 1, right? Now your answer 1 will be found using the solve function. You will trust this solve function that it will find your value for string s1, that is the rightmost value, right? This one. And similarly you will do for s2, right? This solve function will give you the value, and you will simply return answer 1 minus answer 2. Now let's look at the solve function, right? Okay, give me a minute. Yes. So what we are doing, first we understood what are the changing states, right? What were the changing states? Index was your changing state, your type was a changing state, and your previous value was also changing state. So initially we will pass 0 as our previous value, right? We can pass 0 because 0 can be 0, 0, 0 is also an increasing one, right? Okay, now we went to the base case. What is the base case? If you reach the end of the cell, right? If you are on the end, you can say if index is equal to 16, return a 1, right? If you are, how are we solving this digit DP problem, right? If your DP of index index previous value and type is not equal to -1, means you have definitely found the value for it. Return that value, right? What is the limit? Limit is if type is equal to 1, right? If your type is equal to 1, you can say limit will be s of index minus u, right? Means if you had, I have made you understand, if this value was, let's say, 4 and your type was also equal to 1, then you can't exceed 4, right? Your limit will be 4. If your type was 0 and here the value was 4, still you could have gone to 9, right? Why? Because let's say previous index was 5, you picked this 5, and at this position you picked only 2, let's say, then it's obvious thing that this value can be 4 and 9, right? If your type is 0, then you can pick any value up till 9, right? So this is what we have done till this point, right? We are creating a result which is 0. Current value will start from 0, it will go till limit and current value plus plus. If on path is equal to 1, what does this mean? We need to create a increasing subsequence, right? We need to create a increasing subsequence or increasing path, right? So how will we, if this index is on my path, then I need to make sure that current value should be definitely greater than the previous value, right? So if current value is less than previous value, you can't pick this element, right? What does this mean? If you previously picked your previously picked value, right, on the path was, let's say, 4 and current value is 2, will you be able to pick it and make the string or the path, the subsequence increasing? No, you can't, right? I hope I'm making sense. For this position you can pick from 4 onwards till 9, whatever the limit exceeds you, right? So you can pick the element from 4, right? So if current value is less than previous value, simply skip it, continue. You don't think of anything else, go to the next loop. Else, if type is equal to 1 and current value is equal to limit, so your type is 1, you are under restrictions and your current value has also reached limit, then what you can say, you need to pass this type as 1, right? Else you can say type is 0, right? If my type was even my if my say, let's say, if I'm at this position and my type is equal to 1, right, and my limit is, let's say, 7, right, and I'm at 6, right? So if I put a 6 at this point, what will be the value for my next type? If I solve the function, right, if I call the function next time, what will be my type? If I am picking a 6 over here, I am easily bounded. Let's say here was 1, right? So you don't have, and this place was 7, right? So 7 is a type value, you just pick 6. For the next position, can't you pick a 9 and still be in the range? Let's say 170 was the range. Can't you pick a 9 at the next index, right? So if your value is less than the limit value, right, and your type was, even though your type was 1, you can still call the function for the next one with a type value of 0. I hope this made sense to you. If not, ask in the comments. I will literally write everything for you to make it understand. I don't want to make things crack, right? So I hope this part is clear to you, right? So if on path thing is clear to you, not on path will be very clear to you. If type is equal to 1, and if current value has reached limit, simply pass it as limit. Index will get increased. I hope index plus 1, I am missing this thing out. Index always gets increased by 1, right? And your, if one more thing, right, if you are like picking that value, right, then your previous value changes to current value, right? I hope this thing makes sense to you, right? If you're not on path, right, then pick any value you want, right? If your type is equal to 1 and your current value has reached limit, then your type is 1, else your type is 0, right? Similar to this one, right? I hope this doesn't make you think what is going on, right? And at the end you simply return digit dp of index, previous value and type as the result, whatever the result you got from these all the loops, right? And that is it, right? Now let's talk about the time complexity of this problem statement, right? So you are using a dp of 17, 11 and 2. So if you don't know, the time complexity of any dp will be simply what are the changing states in your dp, right? If you have not used any external thing, the ultimate time complexity is 17 into 11 into 2, which was our changing variables at this place. What is this 17? 17 is index. We are taking a value a bit bigger so that we don't crash out. 11, what is this 11? That is the previous value from 0 to 9. Those are 10 values. Just another big value so that you can't crash out. And 2, type value can be 0 or 1. So 2, right? So I hope the problem statement was clear to you. I will give the code in the comments as well. I hope you understood the problem. If you have any doubt on this, please do ask in the comments, and please follow, please subscribe. How will you follow? Subscribe me, and if you have any more doubts, any